So excited to be with you today. Thank you, Serena, for inviting us. So I'll try to convey the following message, if this thing will work. Okay, great. So what I'm going to argue is that the way that we're doing conversations, that we manage conversations today, which is what we call sentence processing. So you give me a sentence and I send you back the meaning of the sentence. Has some limits, although it performs quite well. And what we're trying to do in order to move forward is to push that by adding a dimension into the analysis, the dimension of time, the way that the conversation goes down. And that allows us to go faster and to get to better results when we try to manage conversations. So if I start with a word about myself, so it's very funny because I've just discovered that Marwan and myself were on the same supply chain because one of the brilliant data scientists that we have in our team, Gil, did his PhD with Marwan and now he's in our team. So I'm CTO at Recast, and I have two kind of experience which are relevant to what we're going to discuss today. So I did my PhD in mathematics and game theory. So if you didn't see this movie, Beautiful Mind, so I urge you to see this brilliant movie. And the same thing, the second thing that I've done in my life is a lot of software engineering, and I'm gonna insist a little bit about the tension between math or data science and software engineering, because I'm gonna use software engineering in order to say today that when we use modeling or software engineering tools when we're dealing with conversational AI, so we're cheating. And when we are doing that with data science, so that's the right way to go because it helps us to go faster. So that's a word about myself, a word about Recast if you don't know what we're doing. So Recast, we have developed an artificial intelligence which is very efficient, which brings you the meaning of a sentence. So it helps you to build conversational robots, chatbots. And basically, on top of this, say, technical layer that understands natural language, we've built two products which are from the chatbot world. So the first one is a platform which allows developers to build chatbots on any use case. And the second one is, in order to go faster, something which is already packaged. So these are chatbots who are pre-trained and usually by vertical. So telecom is clearly the most advanced. So it allows you to take something off the shelf and deploy that. So I'm going to use a very simple example when I'm going to show you the way that I think that things should shift from sentence processing to conversational AI. And suppose that we want to book a table in a restaurant, and we want to provide, in order to do that, the number of people, the type of cuisine that we want, and this kind of stuff. So how does it work? Let's start with what's going on today. So if I say a word about the motivation, why are we discussing this thing that is called chatbot, or why are we so interested in NLP? The economic reason behind the whole thing is that call centers or customer service centers are getting a lot of incoming demands, because we users, we become more demanding, and we're very quick to press on a button when something is not very, when we're not happy with something. And clearly, if the number of incoming demands does times 10, we cannot do in call centers times 10 with the number of call center representatives, because there is an economic problem. So the idea is really to automate this kind of workflows which are very easy to treat, right? If it's a low added value, so it doesn't make sense to have a human agent behind the line, it makes more sense to have a robot. So if I give you a couple of examples to what we call automated agent or augmented agent, you can imagine mails, for instance. So the use case will be you send an email to Amazon or whoever, there is a chatbot or a robot that gets the mail, scans what you have written, identifies the intents that you have expressed, so this is a keyword that I'll use afterwards, and as a function of the intents that it has detected or the topics that you have expressed in the mail, it will start the right flow, the right workflow in order to treat that. So that's asynchronous. If you look at that from a synchronous point of view, so it's going to be a chat, right? And in this case, we're going to have a robot that welcomes you when you want to express something related to a customer service, for instance. And as a function of what you've said, either if it's complicated, it will redirect you to an agent, or if it's simple, it will just read the demand. So the way that it is done today is with two key notions, which are called intent and entity. And if I try to say a word about that, so we take a sentence, we try to compare the sentence to classes or to types of sentences that we have already seen that we have labeled. And if it's the same meaning, or if it's something which is close, so we're going to say, okay, it must mean the same thing, so it has the same intent. And in order to take action, I will try to find inside the sentence keywords or expressions which make this sentence actionable. So in this specific example, if I say I want to book a table for 5, so clearly the meaning is that I want to book a table, right? That's a classification problem. And once I've understood that, I'll try to pick up inside the sentence some keywords like the number of people, the type of cuisine, this kind of stuff, in order to be able to really make the reservation, right? So these are the entities that, the 4 entities that you see on the screen. So this is the way that things work today in practically every NLP engine solution that you can imagine, Recast included. Now I want to say a word about the limits of this approach and why we think that we should attack this problem with a different angle. So clearly the main motivation is that it's too slow. I don't know how many of you guys here have developed a chatbot, but if you did, so you very quickly run into one of the following problems. The first one is that you need to predict everything when you build the chatbot. As I said before, when you build a chatbot, so you need to provide the AI with the intents that the user is going to express. And each time that this chatbot sees a new sentence that comes in, it will try to classify it into one of the intents that it has learned. Okay? So clearly in this example, what happens is that when I say I want to book a table for 5 in Paris, everything's cool because the chatbot understands that the intent is book a table. But then there is an exception in the conversation. As a user, I go out from the nominal flow and I say something like, what exactly do you mean by moderate? Because I'm not sure. And this is a new intent that I'm expressing. And if the chatbot developer didn't pre-train the chatbot on this intent, so the chatbot is going to say the famous and frustrating, sorry, I didn't get that. So that's one problem. As a developer, I need to predict everything, and that's quite hard, right? The second problem is the famous context management problem, and here it's even trickier, because what happens is that when I say I want to book a table for 5, everything's cool, but then when the chatbot proposes an option, if I say something very simple like, not sure about that, so there is no intent in the sentence, right? And in order to treat that, I need to know what happened before in the conversation. So this is when I start adding this notion of time that I mentioned earlier. So there is like a dimension which is missing in order for me to manage well the conversation. So when I said earlier that software engineering is cheating, I mean in the sense that the way that we handle this kind of situations today with different NLP solutions is that either we store in the database the last intent that was expressed, or when we have no intent, so we do some default actions. So that doesn't scale because I need to, have this explicit treatment for each context management problem that I'm going to encounter throughout the conversation. So that's the big tada. The way that we've, tried to attack this problem is by going one dimension up. So what we have said is that the sentence itself usually contains an intent, and this is why we were trying to help chatbots learn intents. If you want to add context, or if you want to add the conversation, so you need to take a bigger object. You need to take the conversation. Well, it's not really take the conversation as a whole, because the conversation is quite, usually it's a very big object, it's very long. But if you look at the conversation, what you usually see is mini conversations, like parts of conversations, which are something which makes more sense, or which enables us to process it. And this is what we call frames. And inside a conversation, like the conversation that I've just mentioned, when I want to book a table, so you're going to have 3 frames inside the big conversations. I'm going to express my need first. I'm going to say that I want a table for 5 in Paris for an expensive restaurant. And then I'm going to choose between different options that the chatbot will propose. So that's a second frame. And eventually I will make the reservation. So I'm going to provide my name, my phone number, and that's a third frame. So if you take each of these frames and you let the chatbot learn from this frame, you will create a machine that knows how to handle the conversation around this frame without predefining intents or without using any code. And that was the idea. The idea was to move from a system which is sentence-based. So no more sentence processing. I don't predefine intent. I don't predefine entities. I don't add code in order to manage the transition or the flow between the intents. What I do is that I provide a different machine. So we're in the sequence-to-sequence world now, which is quite different. And I provide this machine with examples of previous or history of conversations. And I let the machine learn the way that these conversations were managed in order for it to be able to manage tomorrow conversations, once again, without code, without intents, without any predefined flow. So as a developer, I can go much faster. I don't need to predefine this stuff, which slow me down. So that's the idea. If I give you 3 snapshots of the chatbot that was developed, or it's not really, you cannot say chatbot that was developed, because it's a machine that takes as an input a history of conversations and then just knows to manage these conversations. So here we were using a data set which is called Task 5. So if I'm not mistaken, I think that we took 1,000 conversations which all discuss booking a table in a restaurant. And you feed these conversations into the machine, and the machine then knows to handle this kind of conversations in the future, although that it's going to see sentences that it has never seen before, probably. So what you see here, if I give you 3, different kinds of users that we usually see. So the first kind is the user that lets the chatbot drive. So the user just says hi, the user is in blue, and then the chatbot says, how can I help you? And the user says that he wants to book a table in a restaurant, and then the chatbot drives the conversation. Where, how many people, stuff like that, okay? There is a very funny thing here that I want to, talk about for a couple of seconds. So note this little silence there. So many people ask us all the time, how close is the time when artificial intelligence or robots will replace humans? So I can assure you that chatbots and AI is yet very dumb. So it's not tomorrow that they are going to replace us, so we can be relaxed. And the specific example here is that in all the conversations on which the machine that we've built has learned the past conversations, there was this weird thing where the chatbot says, okay, I'm on it. And then until the user says silence, the chatbot doesn't go on. Okay? I don't know why. They've just put it in there, the people who have built this task 5 data set. And when we've started playing with the chatbot that was built automatically after reading these conversations, we were always stuck after the, okay, I'm on it. And until we have, provided this silence thing that doesn't mean anything, the chatbot didn't go on. And the reason is that in every conversation that it has learned, there was this silence thing after the, okay, I'm on it. So it's very dumb, right? I mean, unless it gets what it saw in the past, it doesn't know how to go forward. Okay, so when we saw that, we said, oh my God, that's a noise, we should remove that, but no, we should keep that because it transfers very, very well the power of learning. It knows how to imitate very well what it has seen before without, asking itself the question whether it makes sense or not. Okay, so that's very artificial narrow in AI and everything. The second example, is when the user is driving. So here the user gives the chatbot all the required information in a single sentence. So a user that tells the story of its life in a single sentence, and there is no problem for the chatbot. It knows to pick inside this sentence the required information, and the chatbot is not going to ask useless questions, right? In a mixed use case, as you can see here, the user provides part of the information, and then the chatbot completes with the question to get the missing information, and whatever you exclude, it will catch up. So this is what we call skip. And in any event, at the end, it manages to find the required 4 pieces of information in order to do the right API call. So that's about that. This is what we've managed to do. We have managed to build a machine, sequence-to-sequence world, which knows how to take past conversations and then build a mechanism that knows how to manage these conversations without a single line of code, specific code, without any definition of intents or a flow. It just manages to keep up the conversation as a basis of what it has seen. So it's clearly not the end, it's just the beginning. So it's a journey that started earlier this year. And what we have done so far is that, as I said, we managed to, for a given frame, manage the conversation of this frame. The next step would be to step up from a frame to the conversation as a whole. So I believe that the right architecture should be a combination of something which is of a higher level that would manage the transfer between different frames with some kind of a doorkeeper that makes sure that the conversation doesn't diverge. So this is what we call a frame supervisor. And then before the whole thing, you would probably need some system of frame mining, in the sense that we need to be able to identify or to find inside the history of conversations, so real conversations, right, with human agents, the frames that we want to train with the machine. So you're going to get logs of conversations which are very different from one another. You will need a first mechanism to mine the frames from these conversations. Then you will have what I showed you to manage each frame, and a manager to go from one frame to another. So that's the full architecture, at least the way that we see that today. And once you've got this done, so there is some different kind of questions that we will need to tackle. stuff around general knowledge, common knowledge, stuff like that. When I was talking about context management earlier, so that was the context inside the conversation, but then you have context which goes outside from the conversation, so user context, for instance, which is a completely different area. And I guess that the combination of what we have discussed earlier about frames with these three different elements will give us something that will bring us to a real smart chatbot, say, as opposed to what we see today when we deal with chatbots. So I guess that's about that. Thank you.
Thank you, Omer. Thank you very much. Please join. It was very interesting. Just coming back to your last conclusion, do you think with this approach you can have a generic chatbot? Or do you think because of the framing, because also you need to take the context, and if you really want to do this kind of framing and at the conversation level, you will need to be more vertical around or targeted around specific usage. So do you think at the end there will be, it's not really possible to have a generic chatbot, because if you want to do that, you cannot do it at the generic level?
Right, okay, so nice. So I think that the answer is, it depends when. If you want to do something and to put it in production next year, so I think that you should definitely try to narrow it down, and if you concentrate on a vertical or an industry or a family of use cases, so it makes a lot of sense, and frames will help you to go faster. We have in front of us customers like SFR, Bouygues, Vodafone, O2. They have a huge demand to introduce productivity, and they have something like 30, 50 use cases that they want to automate. If we do that with the intent entity method that everyone's using today, it's going to take a year. If you want to do it in a month, so you need to move to something which is faster, and I think that frame will be the answer. Now, if we want to dream a little bit and we look at 2020, which is science fiction today, so I think that it will converge to something that personally I call the mini-me bot, you know. So you are going to have the mini Xavier, mini Olivier, who are going to know our, you know, habits, preferences, this kind of stuff. This is the chatbot that you're going to deal with. It's going to be your interface, and this chatbot will probably, you know, we're 2017, so I need to be careful, but maybe this chatbot will interact with different chatbots behind the scene in order to provide you with the service that you require.
Because when you look at, I recently saw a demo of the new search engine from Google, and the new search engine from Google is going to be a conversation. So do you think it's Google who is going to win in this case for this kind of generic approach, because they have all the data, they got all the history? What's your view on that? Or because it's not possible and it's complicated, you will have to work with, as you say, some specific chatbots, and even Google will have at a point of time to, if he wants to be very performant on a specific question, work with someone or startup or a company who has developed a very vertical chatbot.
Right. So as for the question who is going to win, I think that Recast is going to win.
No, it's more on the technology part. It's more than just to see your view on that.
Yeah, I was joking. So I think that it's very hard to answer, because we keep, you know, judging the future with the tools that we are aware of today, and I don't think that it is something that will scale. I think that the industry of chatbots or conversational AI is going to be disrupted over and over again. Frames is something that is going to disrupt intents and entities that have disrupt the system expert and this kind of stuff that we've known before. So one word about data. I think that it was mentioned earlier in one of the talks that there is a huge difference between data and what we call labeled data. So the fact that you have a lot of data is not necessarily the only way to attack the problem or the only shortcut that you can imagine with, you know, with, say, divide the quantity of data that you have by 10, even by 100, if you know the labels or the tags which are related to the data that you have, you can go much faster. So if you give me a sentence and you say this sentence means that, it is much more interesting than just a bunch of sentences. So I think that clearly the fact that you have a lot of data like Google or the other GAFA players, it allows you to go very fast. You can also imagine different approaches, like what we call collaborative AI, where you are processing labeled data and not just data.
Okay. Some questions from the one over there.
Thanks. I have a question about what you just said, actually. Would it be possible, under your previous scenario, to have a human sort of hovering in real time and just nudging the machine into the right context?
So that's a huge issue. Indeed, when you think about frames, so the baseline is things that you have already seen. If you release a new product, so this new product is not going to be in the history of conversations, so there is no learning base, so you cannot build automatically a chatbot that will know how to handle this conversation. If yesterday things were processed in a certain way, and tomorrow you want to change the workflow inside your business and you want to process it differently, so once again you don't have a history basis and you cannot influence the learning on the way that the chatbot is going to handle that. So we were sharing these ideas with a gentleman called John Ball, who is the head of Einstein at Salesforce, and he indeed identified this challenge of control. I'm not sure how this challenge should be addressed. I think that we can imagine two different solutions. The first one is a mixture of frames and an intent-based solution. And the second one might be maybe throughout the history of conversations, what you want to create is not the sequence-to-sequence chatbot, but rather the flow that you have seen inside the conversations. And once you have the flow, which was generated automatically, so as a developer, you still go faster. Once you have the flow, you can use again the system of intent entity and have full control on the conversation because the flow was generated. So I'm not sure, I don't know, but these are the two ideas that we have in mind in order to attack this challenge of not to lose the control.
Any other question?
Suppose you want to deploy one of your chatbots for a new customer, like not doing restaurants, but doing hotels, for example. How much do it take to retrain the chatbot? Is it only with 1,000 examples provided by, let's say, the customer that is going to work, or do you need much more?
Okay, great. So there are two questions which hide inside this question. The first question is this famous magic number questions. So I think that we should be very careful because the number of examples which are required in order to train a system depends on the complexity of the object that you're trying to build. So if I give you even an example with intent, we were working with the SNCF, the railways company, and the sentences which express the intent to travel, when you say I want to go from here to there, it's a very complicated intent because inside this sentence you have two locations which play a very different role, the departure and the arrival. So I think that 1,000 examples is something that I know that works in a scenario which is not the most complicated that I can think of, but it is not that simple. So maybe it's somewhere, like the average. On simple cases, maybe 100 conversations would be enough, and on more complicated scenarios you will need more. As for the time to market question, how much time it's going to take in order to deploy something like that, so what we're trying to do is to go down from today we need several weeks in order to introduce a chatbot which is intent entity based. With frames we will go down to several days because it's going to be more of like a configuration and there is no real build phase. So you know, our CEO says 9 days, right? So let's keep with that, 9 days.
Okay, Omer, thank you. Thanks a lot.
Thank you.